I'm back with another example, example number 5. You can see here we have a ratio of two exponential functions. So obviously once we see a quotient, we got to start with using the quotient rule for the derivatives. So guys, I'm going to consider this as my f function, this as my g function, and let us recall the quotient rule, which is just f prime times g minus g prime times f divided by the square of the denominator. So using that rule, let us start evaluating the derivative of this function. Piece by piece, guys, we'll try to write all the steps clearly. Derivative of the f function. F function has two pieces, this e to the x and e to the negative x. So derivative of e to the x is just simply e to the x, nothing really difficult about it. Then guys, derivative of e to the negative x is still going to be e to the negative x, but one has to multiply by the derivative of the exponent or the inner, and derivative of negative x is going to be -1, so we got to multiply by -1. Guys, I'm going to keep that in the parentheses. Then I have to multiply by just by the g function. So guys, the g function is just e to the power x, e to the power x minus e to the power -x. Guys, I think I need more space and I want to write everything out in one line. So I'm going to get rid of these formulas here. And let us see if we can squeeze in everything in this whole one line. So guys, that takes care of f prime times g, then minus, we got to do the g prime, which is the derivative of the denominator. Again, e to the power x is e to the power x minus e to the negative x. I got to multiply this by the derivative of negative x, which is just -1, right? And then close the parentheses, and then times, I got to multiply this by the f function, which is e to the power x plus e to the power negative x, e to the power x plus e to the power negative x. That takes care of the whole numerator. I got to divide this by the square of the denominator, which is ex minus e to the negative x whole square. Guys, we cannot leave it like that. We have to simplify, okay? So let us go ahead and simplify and see how far we can get from there. So guys, this is going to be e to the x. Obviously, plus times minus is just minus e to the negative x. That is the first one. And then I still have to multiply that with e to the x minus e to the negative x. So basically, it looks like they are identical. Then minus, guys, here I have e to the x, and negative times negative is positive, positive e to the negative x. And here, what do I have? I have e to the x again plus e to the negative x. So this is plus and plus here, and this is minus and minus here. And then this whole thing is divided by ex minus e to the negative x whole square. Guys, let us make sure and check our work here, because there's a lot of e to the x's here. So there was an e to the x plus, we multiplied by the derivative of that made it -1, and we just wrote the g function. And that's how I like to check my work when I'm working with something which is a little bit more complex. Then I have my g function, e to the x minus e to the, and then multiply by the -1 here, derivative of that, and multiplying by the just the f function. We did that, and we divide by the square of the g function. Then we simplify this becomes minus, this stays minus, and then there's a minus here, then this minus becomes plus, and so I think so far so good. So let us see if we can, sometimes people leave it like this, but guys, I would like to simplify a little bit further. So let us see how we can simplify this a little bit further, and I think I need some room for that. So guys, what I'm going to do is I'm going to try to get rid of this step and see if we can simplify a little bit further. Let's see how far we can go with this. So here, guys, from here, I'm going to take it back right here. So this, we can just like distribute things, right? We can distribute things because there's nothing really common about it. I cannot take out any greatest common factor. So we got to distribute things. So guys, if I distribute this and all that, let us see what do I get. E to the x times e to the x is e to the 2x. Maybe I can take it up here. So I get e to the, okay, maybe that's not a good idea because I need to have everything in one line. So maybe this way I can use this whole thing to write the whole thing in one line. So e to the x times e to the x is e to the 2x, right? Then e to the x times minus, this is going to be negative e to the power 0, right? E to the power 0. I will write all the steps, right? X minus x is 0. That's why I have the 0 here. Then guys, this times this is minus e to the power 0 again, right? Minus x plus x. And then the last term for this multiplication is going to be plus e to the power. I have negative x add up to -2x, right? That takes care of the first product of first two, then minus I have a minus here, guys. Now I've got to multiply these terms. E to the x times e to the x is e to the 2x, right? I will be careful, guys. I will put this in parentheses and then I will distribute the minus once I write out all the terms. And then the next term is e to the x times e to the negative x is going to be just e to the power 0. Same thing, e to the negative x times e to the x is plus e to the power 0. And then the last one is plus e to the power negative 2x, right? And this whole thing has to be still divided by ex minus, so I should write that as well. I have to divide this by e to the x minus e to the negative x whole square. Guys, in order to simplify all this, we have to get rid of the last step, and so that we have space to simplify things. So I'm getting rid of this, and let us simplify the numerator now. There's a lot to simplify here. So guys, this is e to the power 2x. This is e to the power 0 is 1. This is 1, so it will add up to negative 2, right? Negative 1 and negative 1. And then I have plus e to the power negative 2x. Then we are going to distribute this negative, so it's minus e to the power 2x. And guys, this e to the power 0 is 1, and 1 plus 1 is 2, but negative times that positive is negative 2, right? Negative 2. And then the last term is also going to be minus e to the power negative 2x. Guys, I still have to divide this whole thing by the square of the denominator, which is e to the power x minus e to the power negative x whole square. There's a lot of steps, but guys, I want you guys to see how to simplify these things. Now, can we cross out some things? Guys, the good news is that this and this will cross out, and this will also cross out, and I'm only left with, so there was a room, there was a possibility for simplification. And for problems like this, guys, if you see these type of problems in the textbook or on your test, I'm sure your professor is going to ask you to simplify as much as you can, and the professor is not going to allow you to just leave it like the other way that we had, like before I got rid of all that. Okay, you got to simplify something like this, because here a lot of things cross out and we finally are left with negative 4. I know I'm going to ask if I ask this problem on the test, I'm going to ask my students to actually simplify this one. Negative 4 over e to the power x minus e to the power negative x whole square. So guys, this is the final answer in the simplified form. I mean, we cannot simplify any further from here, so we got to leave it like this. Guys, this was not too complicated. You have to just start with the quotient rule, and then one has to carefully simplify things, okay? So these were some examples on finding the derivative of exponential functions. Guys, I will see you next time with derivatives of the trig functions, and there's a lot of them, and then we'll also look at many different types of examples on that as well. Till then, guys, take care. If you need any help, if you have any questions, please reach out to me. I'll be happy to help you with any problems on the derivative section. Till then, take care.